Crash course time. This is not a Java tutorial. This is a generalized modding tutorial specific to MultiLoader-Template. At a very high level, we have this folder, common. This is where most of our code is going to live. We also have subprojects for specific mod loaders, such as Fabric and NeoForge, and those will contain our mod loader entry points. So our goal here is to have most of our code living in common with very bare bones entry points in Fabric and NeoForge. There's plenty of documentation about entry points for both Fabric and NeoForge. I'll have resources for learning Java linked in the description. Service loaders are a huge part of our project here. In practice, we have an interface, IPlatform helper. Say that you want to check if a mod is loaded. We have a method signature to give a mod ID and return a boolean, and we have implementations in NeoForge and Fabric using NeoForge's mod list, or Fabric's Fabric loader get instance is mod loaded. In code, that's a basic layout. Just make sure you include the files. Meta-inf services, we have the full name of the interface. This is a file. Inside, we have one line containing the full location of its implementation. Our services class is how we actually access this. Our platform helper is loaded as soon as the services class is loaded itself, so we see this static initialization. For registration logic, you might want to delay your service being loaded, so I have a basic setup of a private registry helper and then a public static method to get that registry helper. If it's null, then we load the service and then we just return the value. You can check out the load method here, which is backed by Java's service loader. In one of my previous episodes, I showed you different libraries for registering game objects. We went over architecture and registration utils and bookshelf and mimicking Botania's minimal setup. We're going to continue to mimic Botania for the series, but I want to show you something related to service loaders. So Google has AutoService, and if you go back to registration utils, which we talked about previously, it actually uses AutoService in its code. So we look up Google AutoService. You can read all about this online if you want to. It's another service provider interface, just like we went over with Service Loader. It is pretty straightforward to use if you want to take a moment to read through that. Separately, there's a ton of resources for learning architecture if you're interested in that instead, which comes with a huge API for you to use. If we go to the docs for architecture, which I'll have linked below as well, we have ExpectPlatform and platform-specific APIs. It's similar to Google's AutoService, but you do use it slightly differently. There's documentation on customizing that if you want to. And I want to give you a small note on Mixins. Pretty much all Mixins are going to be fine. If you're working on an older version of Minecraft before 26, you might have to deal with intermediary mappings when injecting into a synthetic lambda method. I'll give you one very specific example. The book edit screen, when you're signing it and creating the title for it, it has a limit of 15 characters or less than 16. So if you want to modify that value, I'll actually pull this up real quick. In 1.20.1, Forge is still using Surge intermediary mappings, and Fabric is pretty much always using their intermediary mappings before Minecraft 26.1. We see a function here which generates a synthetic lambda. So if I check this out, text field helper, we see it's a predicate, and a predicate is basically just a function that returns a boolean. So we see this boolean test. So if we want to inject here and change this 16, in our development environment, we would see lambda new. When the player is actually playing the game, we have a different mapping for that method. In Fabric, we have this, and in Forge, we have this. Now, like I said, this is for Forge 1.20.1 and below, and up to 1.21.11 for Fabric. We use intermediary mappings for synthetic lambdas. Now, if you need to find this, there are a couple of mapping viewers online. Linkie is very reliable. Here we see Forge, Mojang via Surge. I'm looking for lambda new 3, which is automatically generated, so it actually exists in a couple of different classes. We are specifically scrolling down and looking for book edit screen, lambda new 3, and we see it uses M98169. And would you look at that, M98169, that's the same method that I'm injecting into. Let's go ahead and get the project. I'm going to click on use this template, then create a new repository. Make sure to include all branches. Give it a good name and description if you want to. This will take a moment to generate, and I'll actually show you why. If you go back to the original project, we have 31 branches. The default right now is 26.1.2, so we're going to change that to 1.21.1 and delete most of the other branches. Let's go to settings. Let's update the default branch to 1.21.1 and update. I understand. We go back and go to branches here, and I'll go to all, deleting almost all of them, and I'm making sure to leave 26.1.2 and 1.21.1. Click reload. Now we have these two branches. One thing we want to go ahead and do is go to settings.gradle, and we can edit this on the website by clicking this pencil icon or pressing E. We're going to scroll down, and we have a note here. This should match the folder name of the project. So for me, I'm changing this to multi-loader example, which is the same name as my project. You click commit changes, and go ahead and click commit again. Now I'm going to click on code and open with desktop, put it in a good location, and click clone, open an external editor. I like to stop this prematurely, go down into my Gradle settings. You can up this amount based on your preference. I'm also going to open settings.gradle and remove Forge. We can also delete that directory as well. You might see this little icon, which you can press to resync your project. I also have the key mapping Control-Shift-O to do that. There's also the option here, a little reload icon to sync all Gradle changes. We synced in about 5 minutes. It might take you a little bit longer depending on your computer, computer, or it might go faster. So now that we have this project, and we talked about how Common has access to vanilla Minecraft, and Fabric and NeoForge have access to Minecraft as well as their APIs, let's see how this works in practice by registering a new Creative Mode tab. We're going to keep it simple, do a new package item, and we are going to refactor in a moment, but first I want to touch on the APIs that are available to us. We're going to follow some conventions, so I'm going to fully type this, mod Creative Mode tabs, and this is a good time to talk about how we register game objects as well in a moment. So we're going to start typing, and we're going to do a public static Creative Mode tab. We type this out and we see net Minecraft world item Creative Mode tab. We're going to call this example tab for now, and we're going to leave this as null, and notice how I'm not making this final. A sub goal here is to avoid static initialization. We don't want to load things based on the class being loaded. We want this loaded based on a method that is called when it's the appropriate time to register game objects. So we're going to have a public static void register method. Our register method is going to have one parameter, which is a consumer, a by consumer, which knows how to take a Creative Mode tab and a resource location and register them. You can also see this consumer as a by function with a void return type. So it takes an instance of a Creative Mode tab, it takes a resource location as an ID for that, and it returns nothing. It just operates on the values it was given. First, we're going to create our Creative Mode tab. So if you try to do this in common code, and we try to do Creative Mode tab .builder.build, we see two expected arguments here, but found 0 for Creative Mode tab row and int column. You can put those values manually if you know what you're doing, but mod loaders handle new Creative Mode tabs in different ways. So we really want to create a service for this that uses mod loader specific logic. So in our base project, our platform helper only has these methods: get platform name is mod loaded, is development environment, and get environment name. Our services, we only have that single platform helper. I spoke a moment ago about delaying the loading of your service, and we're going to do that same thing here. So I want to create a new service, Registry Helper. This is going to be an interface. Going to have the signature Creative Mode tab builder. So in our common code, we just want some way to get a tab builder, and we'll define the service in a moment in Fabric and NeoForge. Back in services, public static registry helper, and you can put null if you want to, or just leave it as a blank field like that, and this should actually be private. Now we have public static registry helper registry, which is a method which always returns registry helper, but if it's null, then we want to load that service. So let's fix this error real quick and do services.registry.tabBuilder.build. So we don't have that issue of the extra parameters here in tab builder because we didn't add them as method parameters. Now we need to actually implement that service in Fabric and NeoForge. So under Fabric, under platform, new class, Fabric registry helper, implements registry helper. I can do Alt Enter to implement all methods, and then instead of returning null, we want to return Fabric item group.builder. So if we look at the return type of this, we can see public static Creative Mode tab builder, and they give you a nice example here as well. If we need to explore their API, we can see it's actually packaged as separate jars. So we see game rule API, group API. So now that we have this class implementing iRegistry helper, we need the service file for it. I'm going to copy this old one and change platform to registry, and inside of this, I'm going to put registry helper. Now we'll do the same in NeoForge. New class, NeoForge registry helper, implements iRegistry helper. And this is a good time to talk about the differences between the APIs as well. NeoForge is actually patching parts of the game, where Fabric, if we go back to talking about Mixins, Fabric is heavily reliant on Mixins, and they're basically just injecting code into the game at runtime, whereas NeoForge patches the jar that we're actually playing with. So what NeoForge has done here for Creative Mode tab is actually patched in this new method that doesn't take any parameters, and it returns a new builder. You see the old builder method here, which NeoForge has marked as deprecated. And if you're not sure about which source you're looking at, just hover over it at the top, and we see this is coming from NeoForge Minecraft merge jar. Let's copy the service file that we created, and I'll paste it here under NeoForge. Inside, change this Fabric to NeoForge. So we now have a Creative Mode tab which uses mod loader specific logic to get a Creative Mode tab builder and then build it. It's expecting a consumer that takes that and a resource location. So we need to call to this consumer.accept example tab resource location from namespace and path constants mod ID example tab. Another part of the crash course is simplifying this because we will use it pretty often, getting a resource location or identifier that's under our namespace. I usually do this in my common class. So we have common class method identifier, which returns resource location under our namespace of the path that we provide. So we could take this and make it a little bit shorter. So now that we have a tab builder, let's actually add some stuff to it, such as an icon, title, and some items to display. For the icon, we need a supplier of an item stack. I'm going to use items.stick inside of a new item stack supplier. I'm going to do a literal translatable component. If this is new to you, you might do translatable instead. and typically you would have item group dot whatever. For now, I'm going to have a literal component of my mod name, and we'll put a stick and a diamond in our creative mode tab. Now we need to wire this up, and like I said, we're mimicking Botania's setup. I'm going to start in example mod under Fabric, going to do public type T void bind. Inside of this, we're going to put registry from Minecraft of generic type T, call that registry, and then a consumer of a by consumer of that generic type and resource location. And we'll call this source. Registering game objects in Fabric is super simple, even with this slightly more complicated setup. I'm just doing source.accept, accepting our generic type with the resource location. So we're consuming those, calling to registry from Minecraft, registry.register, pass in our registry parameter, pass in the resource location, and pass in our generic game object. Take out some of this, and before our init, I'm going to bind built-in registries.CreativeModeTab mod CreativeModeTabs with a method reference of register. So our mod initializes. We have a bind method saying, hey, if you give me a registry and a bunch of game objects and resource locations, I can take all of those pairs and pass them off to a registry. I'm going to copy this logic. I'm going to go down to example mod under NeoForge, paste this in. This is going to be only slightly more complex because we need to pass it to an event. So what I'm doing here, I want a bit easier reference to the event bus that were provided by NeoForge for our mod. So as soon as our mod loads, I want to grab that mod event bus that they provide us and widen that access a little bit. I'm going to comment out this line, and instead of a raw registry, we need to wrap this type because we're going to use a resource key. So every time that we call to this bind method, we know that we are going to be registering game objects to a registry. Let's add a listener, and so the type of event that we want to consume is register event. So we can go to this, and we're just seeing a raw class file right now. I just clicked attach sources up here. Now we see it reloads, and we get a little bit more documentation about this. And if you want to see where that's coming from, I control click on registries, and we see the merge jar. You can go to open in Explorer, open that up, and we see the sources jar. So register event is fired for each registry when it is ready to have modded objects registered. This event is fired for all built-in registries from vanilla, and you see it's fired on the mod specific event bus. That's why we're not using NeoForge's event bus. So during this event, we want to make sure that the registry that we're trying to register to shares the same registry key as the registry that this event is firing for. So if that does match, then we can do source.accept, accept our generic type and the resource location, so we consume those values. Now we do event.register, pass in that registry, pass in the resource location. This time we're doing a supplier for the generic object. We also need to make sure to bind in NeoForge, so we use registries this time, registries.CreativeModeTab, and the same method reference register. It's very similar and accomplishes the same task. There's just a bit of a difference on how Fabric unfreezes the registries versus how NeoForge delegates everything to events. There's a ton to look into. Okay? But for now, let's go to Fabric, run client, and at the exact same time, let's go to NeoForge, mod development, run client. We see the difference between Fabric and NeoForge handling creative mode tabs where they put their arrows differently. For the most part, it's the exact same though. In NeoForge, if you wanted to change the position of your creative mode tab, you could do with tabs before, then creative mode tabs dot spawn eggs. So in most cases, this would have your tab as the first tab on the second page. We have one more thing to note, which is access transformers or access wideners in Fabric. We do have automatic detection for that in the build script. So this is build Gradle for Fabric. You see if the file exists in common source main resources, access widener, then we use that file. In NeoForge, the access transformer, source main resources, metainf, access transformer config. If that file exists, then we use it. This class tweaker is very similar to access widener. It's pretty much the exact same thing. NeoForge also has documentation about their access transformers. They have examples of using that here. Let's talk about plugins real quick. You should be using this, Minecraft Development. It'll make your life a lot easier, save you a ton of time. Stonecutter is an amazing tool, but we are not focusing on it. We're not going to use it in this series. Okay, so let's commit our changes. Let's call this some setup logic, and let's get into refactoring our project. We're going to do a lot of cleanup along the way. Our baseline though, we don't want any occurrence of example mod in our project. So I'm going to remove all this stuff for now. Instead of common class, I'm going to call this the name of my mod, and we're going to be working on More Bows and Arrows today. More Bows and Arrows is a mod that I've worked on in the past. We already have a 1.21.1 version available, so I'm basically walking you through how I wrote the old version of this, some pitfalls I found along the way. Then we're going to port this mod to 26.1.2. There is a reason I'm doing this, and that's mainly that the old code is a mess. I wrote this while I was still learning. You see it was updated one day ago. That was a bug fix, which was me registering to an event inside of an event. So there's quite a few issues with this old code, but we are touching on items, entities, properties, creative mode tabs, and enchantments. So I think this is a pretty good start to a crash course. So let's continue refactoring. I want to change com example mod to match the group that I want. So I'm going to click on example mod and do Shift F6 and do all directories. And I want this to be io.github.json13official.more_bows and arrows. So we refactor and it leaves empty directories behind. We can delete these. Now we see the full path as we want. I'm going to copy this real quick, go to constants and replace the mod ID here. And for mod name, type it out where it looks pretty. This is purely preference. I like to change the names of the mixins to have mixin at the end. And then if it's loader specific, I would put Fabric or NeoForge at the beginning. Copy our mod ID. We need to update our mixins files. So we'll replace example mod with our mod ID. And then inside of these, we're going to replace the package here. Just start typing and it should autocomplete, and replace this error here with just the name of the mixin. We'll expand Fabric, delete the old directory. I'd like to change the entry point names as well. So I'll do more bows and arrows Fabric at the end. And just go ahead and click refactor. Change the mixin name. Make sure your services are correct. Update the mixin file. Fix the package. Fix the mixin name. Inside of fabric.mod.json. Sometimes this might not refactor properly, so just make sure to check this. You want it pointing to the full location of your entry point. Go down to NeoForge, delete the old directories, update the entry point name, update the mixin name, fix the package and the mixin name. We're almost done. I'm going to double tap shift, or there's a search icon where you can look for example mod. We'll go to Gradle.properties. This group should match what we refactored to and put that there. Put our mod name and our mod ID. You can also update the mod author, description, and credits and license while you're here. As well, this Parchment version is technically wrong. Since we're developing against 1.21.1, there is a release for Parchment for 1.21.1. And that's going to be same Minecraft version and then 2024 11.17. And then we can press Ctrl-Shift-O or click this Gradle icon to sync Gradle changes, or go to Gradle and click this refresh icon here. All right, let's search for example mod. You can see this showing up in the runs folders. Go ahead and delete this. This should get rid of the logs. And we don't see the exact text of example mod showing up anywhere. That's what we're looking for. Let's commit our changes. I'll call this refactor. We want to start small, so we're going to look at the bow and arrow item. The spectral arrow and tipped arrow are separately registered items. For now, let's look at what happens when we try to register our own bow and our own arrow with the same model and same textures as the original bow and arrow. Let's create a new class under item, mod items. So to register an item, we need to consume an item and a resource location. Do public static item, call that mod bow. And then right under this, we'll do mod arrow. We have mod bow is equal to a new bow item. Mod arrow is equal to a new arrow item. And then we'll consume those values to register them. We just need to link up this method. I'll press Ctrl-D to duplicate that line. And then we're using built-in registries item and mod items. Same over here. We can look up bow.json or arrow.json. We see the location models item. Copy all of this. Under our common, resources, new directory, assets, more bows and arrows, models, item. This needs to match our item ID. So this would be mod bow for me right now. I'll paste that in there. We can also look up arrow.json and we also see models item, new file, mod, arrow.json, paste that in there. Since we're here, we can also do lang and do en_us.json for a new translation file. And I'll add translations for our item group and then for mod bow and mod arrow. And speaking of our item group, we can go to creative mode tabs. I'll swap out mod items.mod bow, mod items.mod arrow. And then I'll do translatable here with item group more bows and arrows. We're going to refactor this. We can also change the icon and the identifier that we use. And one small thing, we want to register our items before our creative mode tab. So in both of our entry points, we want to make sure we're doing item first. If you want to check the order that you need to register items in, we'll go to built-in registries, and you can go by the order that these are defined in. Down here maintains that same order. So we see things like block, entity type, item, and then much further down we see creative mode tab. Since we ran the tasks before, we can go to all configuration. We see our Fabric run client and NeoForge run client. So I'll go ahead and do both of these again. And I will note this ordering mainly only matters on Fabric, since in NeoForge we delegate registration to an event. So we're going to create a new world in Fabric and NeoForge. We have Fabric on the left and NeoForge on the right. But the only reason I have both open is just to show you that registering game objects like this does work as expected. Going forward, I'm only going to show NeoForge as our main testing, but I will be verifying that Fabric works. Now, do you notice anything if I go and pull out a vanilla bow? You see how the field of view is zoomed in with a regular bow, but this doesn't happen with our mod bow. I can show you the exact cause for this. If we search for is items.bow, and we go to item and hand renderer or AbstractClientPlayer. It's actually here, yeah, but I will pull up both of these. So first, item and hand renderer. This original logic is checking for both hands being a bow or both hands being a crossbow. This is for rendering the hands when you're using the item. So if we look at regular bows and we have two bows in our hands and we go to use the item, only one of them renders. Now compare this to having one of our mod bows in both hands. We still see the other one being rendered when we're using one of them. Now the other thing, the field of view zooming in, this is in AbstractClientPlayer under Get Field of View modifier. We're only checking if the item is items.bow. What we should be doing instead is itemStack.getItem instance of BowItem. So another thing is our arrows. We have one dispenser full of arrows, one dispenser full of our mod arrows. That one fires out. That one dispenses an item. If we check out dispense item behavior and the bootstrap method, we see dispenser block, register projectile behavior for items.arrow, tipped arrow, spectral arrow, but there's no generalized arrow item behavior. Let's start with an easy fix, which is this dispenser block, register projectile behavior. We can actually copy this line because if we check out this method, this is a public method and we're looking at the vanilla code right now. This is one of the rare instances where we can actually call to this in our init and not have any issues really. I'll change this just to look at our usages. We are putting init after game objects are initialized here in Fabric. In NeoForge, it's a bit of a different story. We need to wrap this with an event. So we have FML common setup event. If we go to check this out, this is the first of 4 commonly called events during mod initialization called after register event. So anything that we want to do with game objects needs to happen after those game objects are bound to the registries. Then we can use mod items, mod arrow, and register projectile behavior for that. Let's relaunch our client. We have our dispenser full of our mod arrows. And now those are launched out as expected. Under our Mixin package, let's create a new class, call it AbstractClientPlayer Mixin. This is going to be a Mixin into AbstractClientPlayer.class. The method that we're targeting is getFieldOfViewModifier. NeoForge does provide a ComputeFOV modifier event. I need to explain a bit because it wasn't recording. NeoForge provides that event. You would only use that in your common entry point if you're wrapping that to make sure it only executes on the client. Otherwise, you could set up a separate client entry point. This ComputeFOV modifier event, if we go to client hook, we see get field of view modifier, compute FOV modifier again. But if we go to the sources and check out abstract client player under NeoForge, we can see that they patched in this client hooks get field of view modifier. So we don't want to copy this exactly because other mods might change that return value. As well, we only want to check against versions of our mod bow item so that things don't get wonky with mods affecting other bow items. We're injecting to the very beginning of this. So I copied most of this setup logic and then we're only operating against versions of our bow. So I'm doing this in AbstractClientPlayer Mixin. We're injecting into the top of get field of view modifier and we're marking this as cancelable because we are changing the return value. Callback info returnable set return value. So I'll walk you through what this is doing basically. We start with a modifier of 1 or not changing the field of view at all. If we're flying, we increase that modifier slightly. We recalculate the modifier based on our current speed over the walking speed. If there's no movement from the player, then we set the modifier back to 1 or no change. Then we get our item. If that item is an instance of our mod bow item, which I just created, just mod bow item extends bow item. And then in mod items, we are doing new mod bow item. We're getting the amount of ticks that we've used this item as a range over 20 ticks or 1 second. If we've been using it for more than 1 second, if the progress is greater than 1, then we set it to 1. Otherwise, we square it or multiply it by itself. Then the modifier is inverted, 1 minus progress times 0.15, so it gets shrunk down a little bit. And then we interpolate the current field of view between a range of 1 to our modifier. So we grab a vanilla bow and then a mod bow. We see the zoom in effect with the vanilla bow. And the game crashes with our bow. That's because I didn't have it marked as cancelable before I just ran the code. We use the regular bow and we see the field of view zoom in as expected. We use our mod bow and we see the field of view zooming in as expected. The item texture is not changing. You don't see that arrow actually like pulling in, and we will fix that in one moment. But to fix the item model, we do see in our mod bow JSON, we see item, bow pulling 0, bow pulling 1, bow pulling 2. These are from Minecraft, so we can add Minecraft here. So the current issue is that we don't have this pulling or pull value on our bow. We can go to the vanilla item properties. We see the setup for bow here with items.bow, pull being registered, and down here we see pulling registered. This register method is private, and so is the map that it's giving values to. We have 2 choices here. If you want to go the access transformer route, you can go to copy paste special, and the Minecraft development plugin adds these access transformer entry and access widener entry. You could create a new access transformer file. We can add public before this, and if it was showing up with errors, just reopen the file. To actually see that change and work with that as a public method, we need to reload or resync the project. And while we're doing this, we can also look at item item properties coming from NeoForge and Minecraft merged, which would be the Fabric version. You see NeoForge patches in a public version of that method, and Fabric is already making it public. If you want to look at the access wideners or access transformers, we'll start with Fabric. We have Fabric transitive access wideners, and we see their access widener file here. We can search for item properties, and you see register, register generic, and register custom model data. For NeoForge, we'll open the merge, go to meta-inf, and you see access transformer, and there's no item properties here because they're patching in that method. Our project's still reloading, but we can start setting up our client entry points. So in our common code, I'll do more bows and arrows client, and we'll have a public static void init method. Under Fabric, new Java class, more bow and arrows, Fabric client. This needs to implement client mod initializer from Fabric and implement onInitialize client. Here we need to call to our client init, and our Fabric mod JSON will add a new entry point. This would be under client and add client here. Let me rename this actually. There we go. NeoForge would do something similar. More bows and arrows client NeoForge. There's a couple ways you can do this. I like to have a constructor that takes in an IEvent bus. This should work just fine. Annotating with mod, with your mod ID, and doing dist client. Otherwise, I like doing this. In the common entry point, we check to make sure we're on the client. And if we are, we launch the client entry point and pass it the mod event bus. Let's call it to our client init method here. Open up item properties for reference. Gonna paste this in and then do item properties. We should be able to import that. It took a moment to load. You might need to reload again, or at worst, go ahead and try to build your project just in case it doesn't detect the new access. So we have this now. I'll replace these references. So we have mod items, mod bow. If you want to make this cleaner, you can hover over these, or instead of copying the vanilla code, just pull it from Fabric. You see how these properties have better names here. Technically, that should be solved by using parchment mappings here. We have this in our common build script, so I'm not really sure why it's not working. So we have the same setup for pull of interpolation over 1 second, and then returning 0 or 1 if the player is using the item. We have this wired up in Fabric and NeoForge. Add a small typo. Add a typo which causes the model to fail, and instead of relaunching the whole game, I'll press Ctrl F9. We see build, and the mod is being built again. When that finishes, we go back to the game. We press F3T, and we're back in the game with the correct model. My item model is not changing though. Part of that is because of when this is firing. We're calling to init client as soon as that happens. So just like we delegate common initialization to FML common setup event, we need to do something similar and wrap this with an event. We'll wrap this with FML client setup event and rerun the game. We load back in, and now using our bow, we see the texture changing. So the general rule of thumb in NeoForge is that if you're touching game objects, make sure you're using that logic at the correct time. Your client mod initializer is initialized after your common initializer. So here, our game objects would be registered before client init happens. I want to add a note on how we can write this mixin a bit better. If we look at where we're injecting into this get field of view modifier, we want to copy all of this setup logic, right? And then we want our stuff to happen after we get the item stack. Fabric has this page for mixin examples, which I reference a ton. We go over here, we can see capturing local values. We see without mixin extras and with mixin extras. And if we go to our common build script, we see Fabric and NeoForge both bundle mixin extras, so it's safe to use in common. And you see it's as simple as adding this at local, then the type of the argument, and then the argument. We just need to be in a place where we can capture those. But let's take a step back from this and let's modify our injection point. We're going to be injecting into the method get field of view modifier at the invocation of another method. And if we start typing get, we see get use item. And you can do shift, then do shift after. You also have the option before, which is discouraged because it's brittle, but may be necessary sometimes. I've never used it. So I'm going to fix the method signature by hovering over this or pressing Alt Shift Enter. I'm going to do at local, and that's coming from llamalad7, mixin extra sugar. We want to first capture the float modifier, and we see it doesn't match any or matched multiple. Oh, duh. Yeah, I thought it had to be the generic type. That's on me. So we have at local float F, and let me do also at local item stack, saying we can't capture that. So instead of invoke, we need to change this to invoke assign. We open up the bytecode as well. We can go to get field of view modifier, then this.get use item. We see invoke virtual and a store. So instead of copying all of this setup logic, we just need to copy these names here, modifier and item stack. And we need to make sure this is still marked as cancelable. Cancelable equals true. So instead of our method injecting into the top of get field of view modifier, we're now injecting below this, grabbing float and grabbing item stack, and then performing our logic.